Hello. In this video I wanted to talk about designing and building a drill fixture for a customer. This is sort of typical of some of the work I get in my shop. I don't just get drawings and asked to build them. Sometimes I get a customer comes to me with a problem and they're looking for a solution to that problem. And that was the case in this job. The problem that was given to me to solve by my customer was to find a way to drill through both sides of a C-channel and a piece of sheet piling. The customer is currently building a wharf, and the way the wharf is built is they drive sheet piles in around the perimeter into the mud in the bottom of the lake, and the sheet piles form a wall, and then they backfill the wall and cap it with concrete. Or they backfill the cavity, I guess, that's made by the wall, the three sides of the wall, and then they cap it with concrete. Anyways, the sheet piles are driven in. This is what they look like from the top. It's like they're corrugated. And then what they want to do is run a C-channel along them, which is called a Waler, and then they want to bolt the Waler to the sheet pile. So this is a section. This is a section through the Waler, and it's just two C-channels, and they're bolted through the red here, the holes, and the dotted red line is the center line of the bolt. What they do is they put the Waler up against the sheet pile, and then they tack it here and here just to hold it in position until they can bolt it. The problem they were going to have was trying to drill a 1/2-inch hole through both sides of the channel and through the sheet pile, which is about, I think it's 3/8 of an inch thick. So they asked me if I could come up with a fixture to help them drill that. They told me they had 2 magnetic drills, and so based on that, I have a magnetic drill. It's got about 7 or 8 inches of stroke, so I based it on that, and away I went and designed a fixture. I got the fixture about 80% done, the design, and then they came back and when the fixture was about 80% done, they brought me their magnetic drills, and these are them here. When they brought them to me, it was at that point that I realized these things have less than 3 inches of stroke. The channel's 4 inches wide, the sheet pile's 3/8. I need 5 inches of stroke at least, and I wasn't going to get it with this. So the decision was made that they would lay out all the beams, mark the locations of the holes, bring the beams to me, and I would drill them in my shop. And this is just a piece of channel that's the same size as what they're going to use. The plan was I would drill through here, then they would weld this to the sheet pile, and then they could just go through and use the holes that I had put in as the drill jig to drill through the last 3/8 of the sheet pile that would be here. So what I did was try to figure out how I was going to drill all these holes. There's 400 holes to drill. When I set my shop up, you can see down there is my radial drill, and you can see behind it is the shop door. On the other side of that door, I've got about 100 or so feet to the road, so I could conceivably put a piece 100 feet long in that direction. And then I line it up with the walkway in front of my workbenches, and I can go all the way down to the blue lathe at the far end, which is about 60 feet. So I had set it up so that I could put really long objects on my radial drill. So that was my initial thought. But the beams are 40 feet long, and that's not a problem for length, but they're 200 and some pounds each, and I got to move them a lot of times by hand. And I realized that that's just going to be way too much work. So I have a magnetic drill, as I mentioned earlier. It's this one, and it's got more than enough stroke to do the job. So I thought, well, I'll design a fixture for it, and then I'll just set the beams up on sawhorses and move the drill and fixture down the beams and drill them myself. I didn't want to use the same fixture I'd originally designed for these when I first thought they had enough stroke, because I had this design where I couldn't grab the back of the beam because of the sheet pile being there. So I had some fingers to grip, and I wasn't completely happy with the design, so I thought I'll design something better now that I can take advantage of clamping at the bottom of the beam. So I got that pretty much 100% done. I'd made drawings, it was about to start, and a customer called me back and said that they had concerns that they may not be able to get the holes marked accurately enough for me to drill them in my shop. And I agreed that probably was a concern, and they were worried that I would drill all the holes, they would set them up, and they wouldn't be in the right spot. So we went back to the idea of drilling with their short stroke magnetic drills. So I had to come up with a fixture. What they decided to do was just how I've got it shown here, put a short bit in one drill to get through the first side, put a long bit in the second drill to get through the other side and the sheet pile. Now, the owner's manual for the magnetic drills shows that to develop the full strength of the magnet, you need at least 1 inch thick plate. And my original design for what I was going to use in the shop, I was going to go thinner than that so the fixture was light. And because the drill never needed to be removed from the fixture, I was just going to put a clamp over the front, and then it wouldn't matter if the magnet was at full strength or not, it could never lift off. Because these drills have to be, essentially with this, you clamp the fixture to the beam, you put the first drill on, you drill, you take the drill off, you put the second drill on the same fixture, and you drill the other side. I couldn't really clamp it, it would take too long to clamp and unclamp. So I had to go with a thicker, with the 1 inch plate. I didn't want to go with thinner plate because these drills are used in a vertical configuration where the magnet is up and down, and they're drilling a horizontal hole, and they're drilling, you know, over water. So if the drill was to let go, it would fall, and it would fall into the water. So I had to use at least 1 inch thick plate to make it safe. We couldn't really have any external safety clamps because it'd be just too slow to undo that stuff. So we went with 1 inch thick plate, and I started round 3 of the design and designed this fixture. And so this is the one we're actually going to use. I'll show you how it goes on the beam. There. So the way this works, you have this plate. The magnet on the drill will attach here. It's flat and thick. We'll get a good, it'll attach very strongly, I guess you'd say. This underneath here sits on the top of the beam so that the hole is the correct distance down from the top. To have a hardened drill bushing here to guide the drill while it drills through this side. And then over here we have another hardened bushing, and that guides the drill to go through this angle, which is hard. You have to guide the drill to start in that, or otherwise the drill, when it hits, is just going to walk up up the angle. So the distance between the bottom of this support and this support is made accurately for the beam. And then what you do is you clamp this down like that, and the friction here and here holds the fixture in place while you drill. That was the pretty straightforward part. It wasn't very hard to come up with that. The tough detail on this was getting the clamp, and I had all kinds of ideas how to clamp it, but I had to keep in mind that this fixture needed to be easy to use and quick, because because they had a lot of holes to drill. And I had thought about having a C-clamp that would sit like this and swing out, and I had all kinds of ideas. And finally what I hit on was a C-clamp that you could actually drill through, and that's what this piece is. You can see on this fixture, which is just a copy, they wanted 2 fixtures. You can see the part that's moving is my C-clamp, and the C-clamp is loose, but it's restrained by 4 bolts, and there's slots on each side so that the C-clamp can't fall out and go in the lake, and it's kept roughly in position, but it's loose and can move how it needs to, however it needs to clamp. I put a couple of socketed cap screws here as the clamping surface on the bottom because I wanted 2-point contact to help prevent it from pivoting. And then the top is just a 5/8 screw, kind of like a set screw with a swivel end on it. This would only work if I could sink this. There was no room for a C-clamp was the problem, until I came up with the idea of burying the C-clamp inside of the drill fixture itself. So that's how we got this design. And then this other problem was we had to drill through the C-clamp because it was going to be right in the way. So that C-clamp ended up being slotted, and you can see how the drill can pass through. And no matter where the C-clamp goes in its range of travel, the drill can pass through. So that was the final design, and it took me about 3 days to build both fixtures. And one of the problems was I'd built drill fixtures before and never had any trouble using them in my shop, but there's almost zero clearance between the inside of a drill bushing and the drill bit itself. And when you're drilling out in the field, and I was just trying it out here with the piece clamped in my vise, the drill bit gets hot. You're not using coolant, and it expands and then it binds up in here, and it was really tough. So what we ended up doing was just making a homemade sort of a half-assed hone with a brass rod and a drill, a bit of electrician's tape, and a piece of emery cloth. And I was able to just spin it in here for about 5 minutes, and it just sort of lapped away a couple of thou, and now it works really well. The drill bit doesn't bind, and it goes in easy, and it makes it fast, which is what's really important on this job. So I'm just going to show how this works with the 2 different drills. that's all it takes. Don't know what that was, maybe a couple minutes to drill that hole. The fixture also has to work upside down. So the channel is upside down because there's the lower Waler and the upper Waler. And so I made it with a little, so it'll go on that way. And of course, you'd be doing this with 2 hands, so it'd be a lot easier. And there, and then you just mount the drill upside down in there, and it works for that. So I think the customer's coming in this morning to pick these up. I gotta show them how to use them, but I think they should be happy with that, and it should make their job go a lot quicker, and they shouldn't have to worry about losing their drills in the lake. Thanks for watching.